A simple pendulum has a bob of mass 40 grams and a positive charge for 10 power minus 6 coulomb. It makes 20 oscillations in 45 seconds. Then what they are doing is a vertical upward electric field of magnitude E is switched on in space. How much time will the simple pendulum will not take to complete 20 oscillations? So time period obviously will change because we have changed the effective acceleration. This is a direct formula which we have for which we have 45 seconds for 20 oscillations. That means 45 by 20, 2.25 seconds. That is the 2.5 seconds is the answer to this expression. Now, when this pendulum is there and they are clearly saying the electric field is upwards, okay, a vertical upward speed. So downward acceleration will change. The net acceleration will become G minus QE by M because upward force will be QE, and if I divide by mass it becomes acceleration. So net acceleration acting on the bob is G A equals to G minus QE by M. So now the new time period will become L upon G minus QE by M, and that will be the answer to the question. But we have to find the values. So now we have two values. One is given to us 2 pi root L by G as 45 divided by 20, which is 2.25, and the other, when the electric field is introduced in the question, that to upward direction, so this will decrease to G minus QE by M. So we have to find out this value and then multiply by 20 to get to the value of 20 oscillations. So how we can use this value, because if I don't use this value I have to find out L, and it will be tedious task for pi square L by G n square of this and then find L and put it here. Instead of that, what we can do is I can simply keep L here and write by myself as G, and here also I G put here, and this I shift a little minus QE by M. That way this entire thing already known to us is that 2.25, or you can also write 9 by 4 for easy calculation purpose. Now let's calculate this. This is G upon G minus QE by M. That is what we know. So let's calculate what is the value. I put it as 1 minus QE by mg. Now what are the values given to us? The charge is given to us 4 microcoulomb. You can verify from the question. And mass is given to us as 40 grams, that is 40 10 power minus 3. And electric field given to us as is 2.5 10 power 4. So charge is known, mass and everything is known. So let's calculate 2.25, 1 upon 1 minus, what is charge, that is 4, what is electric field, that is 2.5. So 2.5 into 4 is 10, 10 into 10 power minus 2. Can you see that? So this is this QE is 4, 10 into 2.5 into 4 is 10, and this powers can be written as 10 power minus 2. So QE we got 10 power minus 1. What is mass? That is 14 power minus 3. And if I multiply by G, it becomes 40 10 power minus 2. So I divide by 40 10 power minus 2. So when 2 goes up, it will become 10 by 40 and it will become 1 by 4. So that is what I am getting as a total ratio. Now this is what we have is QE by mg. It is very clear from here that it is 10 upon 40. 10 by 40, yes, 1 by 4. So let's write 1 by 4 here. So 2.25 we can take for the top, and 4 minus 1 3 here. So we get 2.25 into 2 by root 3. Now 2.25 into 2 into 0.57. You should remember 1 by root 2, 1 by root 3, 1 by root 5, 1 by root 7 values. You should know. So easy calculation. So we have 4.5 into 0.57. This much you should calculate. I can calculate here itself. 57 4s are 228, 57 5s are 250, 235. So that will be 2.35. So I'll get 228, and that is 2 point approximately 4 I'm getting. 57 4 to 20, 2. No, not 4. I'll get around 2.6. Okay. So 2.6 I got for 1 oscillations. For 20 oscillations I will get 52 seconds. So the answer is for 20 oscillations it is 52 seconds. So please be very careful with the calculation. Rest the question was not that difficult.